lose your time. So consider the strategy of this problem. This is called a glancing collision, where the objects either make contact at an angle. Like if you look, M2 is suspiciously, I gave you this paper already, right? Yeah, most people have it out. M2 is suspiciously off-center. Well, that's actually realistic. That happens. Objects either collide at an angle, or the resulting, like, imperfect collision results in them firing off at an angle. Glancing collisions, as you're about to see, are so complicated, College Board can't ask you to solve a problem like this in 15 minutes. It's too long. Really, it's too long. So you're safe from this, but they could give you a good chunk of the solution. They could give you some shortcuts by adding more information. Like we're solving, this is overdoing it and having too many unknowns. Not too many to solve it, but too many to make it go fast. Well, they could just give you some of those angles, some of that extra information, and then you could do it in 15 minutes. So you wouldn't see this situation exactly, but you could see an easier version where they either gave you more final speeds or they gave you the angles. Okay, but it's a fun little proof. It's an elastic collision, so and how should we denote after? Should I do primes for after? And we went and we talked about yesterday, elastic, inelastic, completely inelastic. You nod your head or shake your head. No, you got those 3 times? Okay, good. So kinetic energy is conserved. In honors physics, we were allergic to apostrophes. We didn't like that for after. I don't. It's easy to forget them. It's easy to erase them on accident. So if you need something better, speak up. But this is, I think, in the book, and a lot of times you'll see apostrophe for after. Okay. What is the kinetic energy of this object after the collision? Write your answer in terms of K1 and theta 1. Okay. Okay. Actually, that's not too bad. We got to read the whole question. When you get my free responses, do you read all the parts of the question all at once? Or do you read the first part and do it? That's the wrong strategy. When you get a free response on a test, read every part of the question, because there might be some really easy graphs or something at the end, and you can pick up the easy points. Do the easiest points first. What's the kinetic energy of object 2? Write your answer in terms of K1 and theta. Okay. And then the monster. I don't think they could ask this, but that's fun for us to prove it. What's the relationship between theta 1 and theta 2? That's the exit angles. So these two things, they come in. Mass 2 is not moving at all. Mass 1 has velocity v. That's fine. And then they glance off at different angles because mass 2 was off center when they hit. Okay, yeah, that really happens. It's complicated. They could be billiard balls playing pool or something. What's the relationship? You can derive a relationship between theta 1 and theta 2, and that's why I always give this problem, and then memorize it. It's really simple. Does anyone remember it? Or have heard of it before? They're 90 degrees apart. They're complementary. Yeah, always. And you can prove it. You can look it up and prove it. Okay. So actually, maybe this problem isn't so bad. Let's see. We got K1 and theta 1. All right. Well, after the collision, we've got this V1 prime that's really small. It's going to have X and Y components. So it's just going to have its V1 prime cosine theta 1 and V1 prime sine theta 1. The thetas don't need primes. Okay, and we got V2 prime cosine and sine. Okay, and K2 was 0 because that one's at rest, and K1 is just 1/2 mv squared. V for V was V1. Okay, we got that. What's the kinetic energy of the collision in terms of K1 and theta? Okay. Okay, well the mass stays the same. Let's see. 1/2 m v1 prime squared. Did we go over that that's v1 prime dot v1 prime? When you do a vector product with itself to do v squared, you only multiply the x components together and the y components together. That should be part of our... So prime squared, that's why I hate that. It's not v to the 12th. Okay. So when you multiply a vector that has x and y components by itself, it's Pythagorean theorem. I mean, because it could be it should be obvious that if that's some two-dimensional distance along the vector, then that's the hypotenuse of the triangle. And if I square it, that gets rid of the square root that I would have for a squared plus b squared under the square root. Okay, we can back up and do a geometry review. It's part of Thursday. Okay, so it's 1/2 m times that. That's got to be in terms of k1. Well, look. I've got to be v1 prime, v1 prime. So I just need the relationship between v1 prime and v, because I could factor that out. Cosine squared plus sine squared of the same angle is always what? 1. Okay. Let's see if I actually made it anywhere with this. Oh no, okay, write that down. Yeah, okay. Oh, I need to do my conservation of momentum. Okay. So, I might be able to, I could write down, we'll do a different color. I could factor out all the m's are the same. So I could actually do v squared equals v1 prime squared, but I have v2 prime squared. So I need some way to also conserve kinetic energy and then just get rid of that v2 prime, or at least change it back. And then, because if I could solve for this, then I've got k prime, k1 prime. Okay, that's what I'm solving for in part A. Okay. Make it really big. Okay. Oh, that's doing that. Come on. There we go. Good. Okay, by momentum conservation, at first I only have momentum in the x direction. So I have v1 cosine theta plus v2 prime cosine theta. That looks promising, right? My horizontal momentum at the start has to conserve into horizontal momentum going forward. And in the y direction, how much momentum do I have to start? 0. Excellent. Okay. So I'll have v1 prime sine of theta 1 minus, thank goodness the masses are the same size, v2 prime sine of theta 2. Oh, that looks promising. Because there's just a sine ratio between v1 prime and v2 prime. Let's see. I'm going to use the hints. It says I should square both of those equations. 1 and 2. Or solve them. Yep, because then I have theta 1 and theta 2. And add them. That's why I need the whole board. Okay. time. Whoop. Okay. So I wanted, oh, I forgot cosine 1 and cosine 2. I would like to be able to add, use that same identity that I did, and add the cosine theta 2, yes, and the sine theta 2 together, because they're alone, and then cancel that out. So v2 prime cosine theta 2 equals v minus v1 prime cosine theta 1. They would have to, if they gave this problem for real, they would have to shortcut this by giving you the angles, I think. v1 prime sine theta 1. Okay. And then we're going to square both of those equations. So actually, that's really easy. Square, 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 oh, square. Almost amazing. Bless you. But then, I get v2 prime squared on this side only. Cosine squared plus sine squared at the same angle is 1. Okay. So then back in where I had my problem, I had k1 prime plus k2 prime. There's k2 prime without the 1/2 m on the front. So I've pretty much got k2 prime. And if I can just write it all in terms of theta 1s, which is all I've got, then I'm home free. And this first horrible part is over. Okay. Well, v1 squared plus sine times sine squared, that's pretty easy. This thing expands out into a mess, though. I have v squared, I have minus 2v times v1 prime times cosine 1 plus v1 squared, prime squared, cosine squared of theta 1. When I add that to sine, so I basically get that when I add them. So v squared minus 2v1, v times v1 prime. Oh no. Is there a simple way to get rid of that? I need to be rid of that v2. v2 squared. v2 squared can be v squared minus v1 squared. v1 prime squared. Can't it? Because of the kinetic energy equation. Right? V squared equals v1 prime squared plus v2 prime squared. And then I've got an equation that's all of those. Oh, and it's got v2, v1 prime cosine theta. Oh man, this is like Olympic level algebra gymnastics. Oh, and I'm almost out of time, but okay. So we can subtract off the v squareds. We can divide by a negative v1, and we get v1 prime equals 2v cosine theta 1. Wait a minute. I'm going to have to pause. I should have got a 2v1 prime. Oh, I missed a v1 prime from over there. Yeah, there we go. Whoops. So I couldn't leave this off. There's a plus v1 prime, and I gotta stop my video right now.